The sun is acting up and scientists think it might be setting off earthquakes. Specifically, magnitude 8 and above. The kind of quakes that level cities, rupture coastlines, and show up in textbooks for generations. And no, this isn't a conspiracy theory or some fringe pseudoscience bubbling up from the internet's basement. We're talking about real researchers, looking at real.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
Data, and finding increasingly uncomfortable patterns when the sun gets intense, the earth shakes. And it's not just a coincidence anymore. At the center of this brewing storm is something called a coronal hole. Sounds harmless, maybe even poetic, but it's not. Coronal holes are massive regions on the surface of the sun where magnetic field lines open up and let solar wind escape at high speed. Think of them like giant cosmic blow dryers, hurling charged particles across space at millions of miles per hour. When one of these holes rotates to face Earth, the planet gets blasted with solar wind that can distort our magnetic field, mess with satellites, and, as some scientists now believe, potentially trigger massive earthquakes. It's a theory that's gaining traction. Why? Because the timing lines up a little too well. Major seismic events including the catastrophic 2011 Japan earthquake and the more recent 2025 Myanmar quake occurred right when these enormous coronal holes were aimed directly at Earth. And we're not just talking about one-off events. There's a growing body of evidence suggesting a pattern, a correlation between these bursts of solar energy and high-magnitude earthquakes on Earth. The mechanism, that's where things get wild. First, there's the electromagnetic component. When solar wind hits Earth, it causes disturbances in our magnetosphere and the ionosphere. That energy doesn't just stay in the sky. It filters down, interacting with the planet's surface and possibly with its internal systems. Researchers have observed electromagnetic anomalies that show up days or even weeks before major quakes. We're talking shifts in ionospheric electron density, strange radio signals, fluctuations in the Earth's naturally occurring electromagnetic resonances. Stuff that satellites like NASA's Solar Dynamics Observatory are picking up in real time. Add to that ground-based sensors that detect sudden blips in atmospheric electricity, and you've got a growing pile of breadcrumbs leading to the same conclusion. Something happens in the electromagnetic spectrum right before the ground breaks. But here's where things really take a turn. A new class of scientific hypotheses is expanding the conversation beyond just surface-level tectonics. Some researchers now believe that a natural nuclear reactor, yes, a georeactor, exists at the Earth's core. A self-sustaining fission reactor buried beneath miles of mantle, generating plasma and potentially affecting geological behavior. If that's true, and it's influenced by external forces like solar wind pressure or magnetic field disturbances, then we're not just looking at solar wind as an annoyance, we're looking at it as a trigger for deep planetary change. The idea is that when the sun lets loose with a high-velocity stream of solar wind, it doesn't just rattle Earth's magnetic field. It may also exert pressure on internal plasma systems, subtly weakening molecular bonds along fault lines. Faults that are already under immense stress from tectonic movements. The added nudge from above might be just enough to tip the scales. And the thing is, we're in a solar maximum right now. That's the phase in the sun's 11-year cycle when sunspot activity peaks and, along with it, coronal holes and solar storms become far more frequent. During this period, the likelihood of the sun firing off more of these high-speed solar wind streams increases dramatically. Translation: more potential for geomagnetic disturbances, more potential for electromagnetic anomalies, and more potential for earthquakes. It's not all theory and abstract data, either. There are real-world implications and real-world hotspots that scientists are paying close attention to. One of the biggest concerns is the Pacific Ring of Fire. This belt of seismic and volcanic activity loops around the Pacific Ocean and includes some of the world's most earthquake-prone areas: Japan, Chile, Alaska, and the Pacific Northwest of the United States. These regions sit atop subduction zones, where one tectonic plate dives beneath another. They've produced some of the largest earthquakes in recorded history, and right now, they're disturbingly quiet. In particular, the Cascadia subduction zone, which stretches from Northern California to British Columbia, has been eerily silent for centuries. Scientists know it's locked, meaning stress is building. And now, with increased solar activity potentially influencing stress dynamics in the crust, the risk factors are stacking up. What's even more unsettling is that electromagnetic signals linked to earthquake precursors have already been observed in these regions. Drops in plasma density, fluctuations in the Schumann resonance, sudden blips in atmospheric and ionospheric data that don't match normal weather or geological patterns. We're seeing all the red flags, and we're seeing them from space. This is where the technology comes in. And honestly, it might be the only thing keeping us ahead of the curve. Satellites like the Solar Dynamics Observatory and ground-based monitoring stations are now able to detect the faintest electromagnetic changes in the environment. These sensors track everything from solar wind velocity to electron density in the upper atmosphere. When paired with seismic data, they provide a more complete picture of what's happening before an earthquake hits. In the past, earthquake prediction was all about tracking stress accumulation and waiting for statistical patterns. Now, we're moving toward a model that includes space weather, plasma physics, and electromagnetic signals. It's a shift in thinking that's reshaping how we understand tectonic behavior, not just as a product of Earth's internal mechanics, but as part of a much bigger cosmic system. This doesn't mean we can predict the exact time and place of the next big one. Not yet, but it does mean we're starting to recognize the warning signs with more clarity. And if this data is right, if coronal holes and solar storms really are nudging Earth's fault lines toward failure, then our ability to forecast major quakes could take a massive leap forward. Which brings us back to the risks. Right now, the convergence of solar maximum activity and long-term tectonic buildup in known seismic zones is creating a perfect storm. Places like Cascadia, the Alaskan coast, and subduction zones around the Pacific aren't just due, they're overdue. The silence isn't comforting, it's ominous. And it's not just about the ground shaking. It's about what comes before it: the strange radio signals, the ionospheric anomalies, the subtle electromagnetic cues that are only now becoming legible thanks to cutting-edge tech. Signals that, in hindsight, have appeared before some of the biggest earthquakes of the last 2 decades. This isn't fringe science anymore. It's a multidisciplinary effort, pulling in researchers from geophysics, plasma physics, space weather, and nuclear science. The old model where earthquakes were seen solely as the result of mechanical stress is no longer enough. Earthquakes might not just come from within. They might be set off by forces 100 million miles away. And if that's true, then early warning systems have to evolve. Disaster preparedness agencies need to factor in solar activity. Governments need to start treating space weather the same way they treat tsunamis and hurricanes, as a real and immediate threat to infrastructure, lives, and stability. Because if a massive coronal hole is facing Earth during a period of tectonic buildup, we're not just at risk, we're on borrowed time. The Earth-Sun connection is no longer just poetic. It's practical, it's scientific, and it's potentially life-saving. If you live near a major fault line, now's the time to get prepared. Emergency kits, evacuation plans. Pay attention to seismic updates, but maybe start paying attention to space weather too. Because the sun, it might just be the biggest wild card in the entire earthquake equation. So what do you think? Could solar storms really be influencing earthquakes? Is this a revolution in science, or just a fascinating coincidence? Let me know your thoughts in the comments. And if you want to keep up with more jaw-dropping theories, science shakeups, and chaotic deep dives, don't forget to like this video, subscribe, and share it with someone who needs to hear this. Because when the ground starts rumbling, you'll want to know why. And it doesn't stop there. Because once you start looking at the data, really looking, it's like peeling back a layer of reality you didn't know existed. Let's talk about these electromagnetic precursors for a second. Scientists have been seeing strange things right before earthquakes for years. We're talking unexplained radio signals, flickering lights in the sky, sudden drops in ionospheric electron density, even bizarre animal behavior. For the longest time, it was chalked up to coincidence or dismissed as anecdotal. But when multiple satellite missions and ground stations start picking up the same weird signals before multiple major quakes, that's no longer just noise. That's a pattern. Take the Schumann resonance. It's like the Earth's natural hum, a set of ultra-low-frequency electromagnetic waves that resonate between the Earth's surface and the ionosphere. It's been observed that these frequencies shift before some large earthquakes. Now, if these changes correlate with solar wind activity from coronal holes, that's where things start clicking together like puzzle pieces you didn't even know were related. And sure, skeptics will say correlation doesn't equal causation. But at some point, when the same signs appear over and over before a magnitude 8 quake, and the sun just so happens to be flinging solar wind our way each time, you have to ask the hard question, what if we've been underestimating the sun's influence this whole time? The answer may not be comfortable, but it's becoming unavoidable. Because this isn't just about the 2011 Japan quake or the Myanmar quake in 2025. It's about how this phenomenon could be playing out right now, in zones of silence. And yes, we're talking about Cascadia again, because that stretch from Northern California to British Columbia is a sleeping monster. It's locked, meaning the plates aren't sliding. They're stuck. Pressure is building. The silence. That's not safety. That's suspense. Scientists have already observed electromagnetic anomalies in that region, including unexplained atmospheric changes and fluctuations in the ionosphere. And with the sun entering the most active phase of its cycle, those coronal holes are appearing more frequently, aimed right at Earth like cosmic spotlights. This isn't fear-mongering, it's just the math. The Earth's tectonic plates don't move on human timelines. They don't care if it's a weekday or a holiday. But when you add in a layer of external pressure, literally pressure from space, it might just be the final straw. Because here's what's wild. Some researchers now believe that fault lines may not need a major tectonic shove to rupture. A subtle shift in electromagnetic conditions might weaken the already fragile friction along those lines, especially in subduction zones where pressure has been quietly stacking for decades. And that's where the internal Earth theories come back into play. This idea of a georeactor at the core of the planet. It's not science fiction. Some researchers propose that a natural nuclear fission process deep within the Earth could be producing heat, plasma, and even helium-free emissions. Now, whether this reactor exists or not is still debated. But here's what matters. If it exists and if it's affected by external solar pressure or electromagnetic changes, then the Earth isn't just reacting to tectonics. It's reacting to space. That would mean earthquakes are more than just geological events. They're potentially astrophysical events too. And that, frankly, would change everything. Suddenly, earthquake forecasting isn't just about measuring ground movement. It's about monitoring space weather, solar wind velocity, and plasma density in the upper atmosphere. It's about combining seismology with astrophysics. And that's exactly what's happening. New technologies are coming online that give us more insight than ever before. We're talking high-resolution solar imagers, plasma particle detectors, magnetometers, and ionospheric sensors. Satellites that monitor the sun in real time. Ground sensors that detect electrical currents running through the soil. These systems are helping scientists identify subtle precursors, those invisible signals that show up before the Earth breaks open. And while we're not at the point of predicting the exact time of an earthquake, this integrated model combining electromagnetic, solar, and seismic data is giving us an early edge. A heads up that something's shifting. It's not just theory anymore. It's tools. It's models. It's actionable. So why isn't this mainstream yet? Well, because it's new. And because it challenges a long-standing paradigm that earthquakes are strictly a mechanical process, rocks grinding, pressure releasing, that's it. But reality is rarely that simple. And when the evidence starts stacking higher than a tectonic plate boundary, you've got to evolve the model. And it's not just academics saying this. Governments and risk management agencies are starting to take notice. Some earthquake-prone countries are beginning to include electromagnetic and solar activity in their monitoring protocols. Because they have to. When you're dealing with cities that sit on fault lines, early warning, even minutes, can save thousands of lives. The stakes couldn't be higher. But the other reason this hasn't broken wide open, it's unsettling. The idea that something happening 93 million miles away could shake the ground beneath your feet, it feels like too much. It removes control. It makes our planet feel even more vulnerable, more reactive, more alive. But the truth doesn't care how it makes us feel. And right now, the truth seems to be this: earthquakes may not be entirely Earth-made. That's the shift. Because now, We're looking at a planet connected electromagnetically, energetically to the solar system in ways we're only beginning to understand. The science is still developing, but the signals are real. The data is consistent, and the stakes couldn't be higher. So what do we do with that? First, we stay alert, especially if you live in a seismic hotspot. Stay informed, not just about local tremors, but about what the sun is doing. Because in this new era of space weather integrated forecasting, solar storms might be the next red flag. Second, we support the science. This kind of multidisciplinary research combining plasma physics, seismology, atmospheric science, and space weather is hard to fund and harder to explain to the public. But it's absolutely essential if we want to avoid being blindsided by the next big one. And finally, we talk about it. We get the information out. Because earthquake preparedness has always been about awareness. And if electromagnetic signals, solar wind, and coronal holes are part of the picture, then they need to be part of the conversation. Because one day soon, a solar event will hit. A coronal hole will open, sending a surge of high-speed particles toward Earth. The magnetosphere will shimmer. The ionosphere will shift. Somewhere, a fault line will already be on edge. And when that final trigger hits, whether it's from below or above the ground, will move. So let's not pretend this is all business as usual. We are, quite literally, living in a new age of Earth science. One where the lines between space and geology blur. One where sunspots might carry seismic consequences. One where understanding the next earthquake might mean watching the sky as closely as we watch the ground. And if you made it this far, clearly, you're not just here for the headlines. You're here for the truth. The weird, complicated, often overlooked truth about how our world really works. And look, no one's saying we should throw out everything we know about earthquakes. The crust still grinds. The plates still slip. Fault lines still store energy like a ticking clock. But what if we've only been watching half the mechanism? What if the final push doesn't come from below, but from above? That's what's so unsettling and so game-changing about all of this. Because for decades, we've relied on models that assume the Earth's crust is a closed system. Internal stress builds up, a fault fails, and boom, earthquake. But now we're seeing signs that the system isn't closed. It's connected. A chain of invisible signals stretching from the core of our planet to the surface of the sun. And when all those links align, things move. It's not comforting, but it is compelling. Especially when you realize how blind we've been. Solar weather has always been treated like a satellite problem, something for NASA to worry about. But maybe it's also a Cascadia problem, a Japan problem, a Chile problem. Because if coronal holes and geomagnetic storms are part of the seismic puzzle, then we've been underestimating risk in a massive way. And in a world full of uncertainty, one thing is now crystal clear: our planet listens to the sun more closely than we ever thought. So don't shrug off the next solar storm report. Don't tune out when scientists start talking about electromagnetic signatures or plasma flow. That space weather segment might be your early warning. Not for a power grid failure, but for the ground shifting beneath your feet. Thanks for sticking through this one. If this shook your worldview even a little, hit the like button. Subscribe if you want to stay ahead of the curve, because we're just getting started with the science that changes everything. And drop your take in the comments. Are we finally seeing the full picture? Or are we just scratching the surface of something way bigger than we realize? Either way, the sun isn't just rising, it's warning.